Welcome to the DIY Honda Garage channel. The DTC P0462, which pertains to the fuel level sensor, also known as the fuel gauge sending unit, circuit low voltage, indicates a problem specifically related to the sensor's ability to send the correct voltage signals regarding fuel level to the vehicle's electronic control unit, ECU. This error can lead to incorrect readings on the fuel gauge, which measures the amount of fuel in the tank. The fuel gauge sending unit is typically located in the fuel tank, and it plays a crucial role in accurately sending the status of fuel levels to the vehicle's dashboard. For the Honda CRV models from 2011 to 2016, encountering this error code necessitates immediate attention to ensure proper fuel gauge functionality and prevent any possible operational issues related to fuel levels. Understanding the implications of this DTC is essential for maintaining your Honda CRV's performance and reliability. The DTC P0462 primarily involves the fuel level sensor, which is specifically known as the fuel gauge sending unit. This component is responsible for measuring the volume of fuel in the tank and sending corresponding voltage signals to the vehicle's dashboard fuel gauge. A signal reflecting the current fuel level allows the driver to determine how much fuel is available. Typically, the fuel gauge sending unit is located within the fuel tank itself, making it essential for its functionality. If this sensor fails or experiences low voltage, it can disrupt the entire fuel level monitoring system, resulting in inaccurate readings displayed to the driver. Thus, recognizing the location and role of this component is crucial when approaching troubleshooting processes. Several possible causes can lead to the triggering of DTC P0462. First, poor connections at various points within the circuit can disrupt normal operation and lead to low voltage readings. Loose terminals in the connections to the gauge control module or the fuel gauge sending unit can also be a contributing factor, which emphasizes the need for complete visual inspections. Furthermore, a faulty fuel gauge sending unit could be to blame if voltage readings are consistently low, as the unit may not be correctly sending the necessary signals to the ECU. Lastly, wiring issues such as shorts or breaks within the line connecting the sending unit and the module can severely impact voltage levels, leading to this specific error code. When facing DTC P0462, certain symptoms may arise that clearly indicate issues with the fuel gauge system. The most obvious symptom is the incorrect fuel gauge readings. This may manifest as a gauge showing empty when there is fuel present or moving erratically. Additionally, drivers might experience a situation where the fluid level fails to display altogether, leaving them unaware of fuel status. Such discrepancies can lead to potentially serious drivability issues, such as running out of gas without warning. This can pose risks not only to the vehicle's operation, but also to driver safety. Recognizing these warning signs early on is crucial for ensuring timely repairs and avoiding further complications. The first step in troubleshooting DTC P0462 begins with problem verification. Start by turning the ignition switch to the on second position to power the vehicle's electrical systems. Following this, it is critical to clear the DTC using the Honda Diagnostics System, HDS, which allows the system to reset and prepares it for diagnostics. After clearing the DTC, wait 5 seconds before checking DTC status once again using the HDS. Ideally, if DTC P0462 is re-indicated, then the failure is confirmed and you can proceed to the next step in your troubleshooting process. Conversely, if no DTC is shown, this may indicate an intermittent failure. thus necessitating a check for poor connections or loose terminals in the gauge control system. The second troubleshooting step focuses on examining the fuel gauge sending unit more closely. Begin by turning the ignition switch to the lock 0 position to ensure safety during the inspection. Next, you will need to remove the access panel located on the floor, providing access to the fuel system components. After accessing the unit, disconnect the fuel tank unit 4P connector to isolate the fuel gauge sending unit for testing. With the connector removed, turn the ignition switch back to the on 2 position and again wait 5 seconds. Utilizing the HDS, check for any changes in the DTC status. If DTC P0463 appears, this indicates a high voltage issue within the fuel gauge sending unit, prompting a replacement. If DTC P0463 is not displayed, it indicates that the sending unit is operational, and you should proceed to the next step. In Step 3, troubleshooting shifts towards measuring the voltage within the fuel gauge circuitry. The first action is to ensure the ignition switch is turned on, how, which powers the electrical components. With the fuel tank unit 4P connector still disconnected, measure the voltage between designated test points 1 and 2 on the fuel gauge plus line. This will involve checking test point 1 at the fuel tank unit 4P connector number 2, identified by a yellow wire, and test point 2 against a solid body ground. The primary goal here is to confirm the presence of battery voltage. If battery voltage is indeed present, it indicates that a problem exists further in the circuit, prompting the need to move on to Step 5. Conversely, if no voltage is measured, this suggests potential wiring issues, leading to Step 4 for deeper inspection. Step 4 concentrates on investigating for shorted wires in the fuel gauge plus line. Start by turning the ignition switch to the lock 0 position to ensure safety during this process. After this, remove the gauge control module to gain access to the connections. Disconnect the gauge control module 32P connector to isolate the module. Following this, continuity testing is conducted between test points 1 and 2. Similar to prior steps, ensuring both connectors remain disconnected. Test point 1 remains the fuel tank unit 4P connector number 2 wire, and test point 2 is again a solid body ground. Confirming continuity here will indicate a short in the fuel gauge plus wire. If continuity does exist, this signals that there is a short somewhere in the wiring that needs repairing. However, if continuity is absent, the wiring is deemed intact, leading to potential failure within the gauge control module itself. Step 5 involves thorough checking of the gauge control module to ensure its proper functionality. Start by reconnecting the gauge control module 32P connector to power it up again. After reconnection, remove the fuel tank unit itself to continue testing accurately. Ensure that the fuel tank unit 4P connector is reconnected, making certain that all terminals are in place. Now, turn the ignition switch to the on 2 position once again and clear the DTC utilizing the HDS. Afterwards, simulate an empty tank condition by adjusting the float to the E-empty position. It will be crucial then to observe the fuel gauge. If it moves to the empty position, this confirms that the gauge control module is functioning correctly. If the gauge does not respond as expected, replacing the gauge control module becomes necessary. Final repair verification is essential to ensure that the previous troubleshooting efforts were successful. Begin by turning the ignition switch to the lock 0 position, which ensures safety while handling components. Proceed by reinstalling all removed parts in the order they were taken out. This includes ensuring all connectors are securely attached. After all components are back in place, Turn the ignition switch back to the on. 2. Position to check the system. Resetting the powertrain control module PCM using the HDS tool is absolutely necessary in this stage, as it clears any previously stored error codes. Following a successful reset, performing the PCM idle learn procedure will ensure that the vehicle's engine management systems are recalibrated. This thorough check will also include verifying that no pending or confirmed DTCs, specifically DTC P0462, are triggered post-repair. For effective prevention of DTC P0462 and similar issues, regular maintenance practices are highly advised. Start by scheduling routine checks of all connections within the fuel gauge and related circuitry. This includes connectors at both the fuel gauge sending unit and the gauge control module. Furthermore, conducting periodic inspections of the wiring harness can identify frayed or damaged wires that might lead to potential voltage loss. As vehicle technology continually evolves, it is also crucial to keep the PCM software updated to prevent issues that may arise from outdated programming. Timely updates ensure the system operates using the most recent enhancements and fixes that Honda provides. Adopting these preventive measures can significantly enhance the longevity and reliability of your fuel gauge system. In conclusion, the presence of DTC P0462 signifies an underlying issue with the fuel gauge signal system that requires attention. It's imperative to address all aspects of the fuel level sensor circuit, including verifying connections and examining potential wiring faults. Following a step-by-step troubleshooting approach is essential for systematically identifying the root cause of the error code. By conducting thorough inspections and utilizing proper test equipment like the HDS, repairing and verifying functionality becomes a structured process. Directing attention to preventive maintenance can also mitigate future occurrences of this DTC. Ultimately, understanding and addressing DTC P0462 is critical for safe vehicle operation and maintaining the overall reliability of your Honda CRV. Please like and subscribe to the channel. See you next time.